हेलो गाइस, वेलकम बैक टू माय चैनल वंस अगेन। और आज हम लोग बात करेंगे IOQM एग्ज़ाम 2025 की, जो कि आपका 7 सितंबर 2025 को ऑर्गेनाइज करवाया गया है। सो इन दिस वीडियो वी आर गोइंग टू डिस्कस द क्वेश्चन नंबर 1 to 10 ओनली। सो चलिए शुरू करते हैं। सबसे पहला सवाल ये है कि इफ 60% ऑफ अ नंबर x इज़ 40 देन व्हाट इज़ x परसेंटेज ऑफ y। तो जैसे जैसे आपको स्टेटमेंट दे दी गई है, सेम स्टेटमेंट को आपने मैथमेटिकल फॉर्म में हमने कर लेना है। दैट मीन्स 60% ऑफ अ नंबर x इज़ 40। 60% ऑफ अ नंबर x इज़ 40 which implies x is equal to 40 into 100 upon 60। तो यहाँ से हमारा x आएगा 400 अपॉन 6। फर्दर आगे बोल रहा है देन व्हाट इज़ x परसेंटेज ऑफ y। दैट मीन्स x परसेंटेज ऑफ 60 हमको निकालना है। दैट व्हाट इज़ x परसेंटेज ऑफ 60। x परसेंटेज निकालने के लिए क्या करेंगे, x बाई 100 इंटू 60 दैट इज़ इक्वल टू 400 डिवाइडेड बाई 6 और डिवाइडेड बाई 100 करेंगे इंटू 60 करेंगे। सो 6 यहाँ पे आपका काटेगा 60 को, एंड बाय सिंप्लीफाइंग दिस एक्सप्रेशन you will get 40. So x percent of 60 will be 40. So your 40 is your correct answer. Now question number 2. Question number 2 reads out, find the number of positive integers n less than or equal to 100 which are divisible by 3 but are not divisible by 2. तो सबसे पहले हम लोग इस क्वेश्चन में क्या करेंगे, वी विल फाइंड आउट द टोटल नंबर ऑफ इंटीजर्स विच आर मल्टीपल ऑफ 3. सो दोज मल्टीपल ऑफ 3 दे विल बी divisible by 3. So the numbers which are less than or equal to 100 but which are divisible by 3 are 3, 6, 9, 12 and up to so on. And the maximum number which is less than equal to 100 and is divisible by 3 is 99. So if you observe this pattern, so you see that this list of numbers, it forms an AP whose first term is A1 is 3, D is, that is common difference is again 3, and let us find out there are how many terms in the list of these numbers. So मान लेते हैं कि हमारा AL है दैट वो 99 है, या फिर AN है उसको हम लोग 99 मान लेते हैं, और हमें जनरल टर्म का फॉर्मूला मालूम है AN इज इक्वल टू A1 प्लस n माइनस 1 इंटू D. So AN is 99 which is equal to 3 plus n minus 1 into 3. इस 3 को बेटा हम लोग क्या करेंगे कि लेफ्ट साइड पे लेकर के जाएंगे, सो इट विल गेट सब्ट्रैक्टेड फ्रॉम 99. 99 minus 3 is 96 is equal to n minus 1 into 3. Now dividing both sides with 3 we will get 96 by 3 is equal to n minus 1. So which is equal to 32 is equal to n minus 1, which implies n is equal to 33. But this list of 33 numbers, it also include the numbers like 6, 12, 18 which are also divisible by 2. So but we need to exclude those numbers. We need to exclude those numbers which are divisible by 3 but are not divisible by 2. So this is we require to find. So in order to find out the required number of numbers, we need to exclude 6, 12, 18, 24 and so on. So let us find out the numbers which needs to be excluded from these 33 numbers: 6, 12, 18, then 24, and the maximum number will be 96, as 96 is divisible by 6. So here A1 is equal to 6, common difference is 6, and AN is equal to 96. Again by applying formula of general term we will get AN is equal to A1 plus n minus 1 into D. So 96 will be equal to 6 plus n minus 1 into 6. 96 subtracted, when we subtract 6 from 96 we get 90, which is equal to n minus 1 into 6. Divide both the sides by 6, we will get 90 by 6 is equal to n minus 1. So which will return n minus 1 is equal to 15, which implies n is equal to 16. So we need to exclude these 16 numbers from 33. So the required number of numbers which are divisible by 3 but are not divisible by 2 are 33 minus 16, which is equal to 17. So your required answer is 17. Now question number 3. The area of an integer sided rectangle is 20. Mind it, here it has been mentioned that the sides of a rectangle, they must have some integral value. What is the minimum possible value of the perimeter? You have been given that the area of rectangle, so area is length into breadth, which is 20, and it has been given in the question that the area of an integer sided rectangle, that means the side of the rectangles, they must be integers. So let us find out the possible number of pairs for L and B such that they are integers and the product is 20. So first is 20, L is 20 and breadth is 1, or length is 10 and breadth is 2, or length is 5, breadth is 4, or length is 4, breadth is 5, or length is 2, breadth is 10, or length is 1 and breadth is 20. These are only possible pairs for L and B. So we need to minimize perimeter, and we know that perimeter is 2 times L plus B. For the pair L is equal to 20, B is equal to 1, perimeter will come out to be 20 plus 1 is 21, 21 into 2 is 42, and for the pair L is equal to 10 and B equal to 2, perimeter will come out to be 10 plus 2, 12, 12 into 2, 24, next 5, 4, so we will get 5 plus 4 is 9, 9 into 2 is 18, again for 4, 5 you will find out that perimeter will again be 18, and for next pair, that is L is equal to 2, B equal to 10, you will find out perimeter will be 24, and for L equal to 1, B equal to 20, you will find out that perimeter is 42. But we need to minimize the perimeter. So the minimum value out of these is 18. So your required answer of this question is 18. Now let us now move forward to question number 4. How many isosceles integer sided triangles are there with perimeter 23? Again, here in this question, you have been given that there is a triangle which is isosceles, and the sides of triangle, they must have some integral values. That means sides of this triangle, they are some integer, and it is also being given here that the perimeter of this triangle is 23. Further, this triangle is isosceles triangle. We know that in an isosceles triangle, two sides of this triangle, they are equal, and one is not equal to the another side. So let us assume that the two equal sides be x, and the other side is y, and it has been given that perimeter of this triangle is 23. So we will get the equation 2x plus y is equal to 23. This is a linear Diophantine equation in which the solution x and y, they will be some integer. So let us find out the possible values of x and y which will satisfy this equation. So that will constitute your answer. As it has been asked, how many isosceles integer sided triangles are there with the perimeter 23? In order that x is an integer, y must be some odd number. Otherwise, when you will subtract y from 23, you won't get any even number, and as a result of which you won't be able to get x as an integer. So in order to satisfy all the conditions of the given question, y must be some odd integer. So the least odd integer which is positive, as the side of triangle, they cannot be negative, is 1. When y is equal to 1, you will get 2x is equal to 22 and x is equal to 11. Then next odd positive integer is 3. When y is equal to 3, x is equal to 10, and when y is equal to 5, x is equal to 9. When y is equal to 7, x is equal to 8. When y is equal to 9, x is equal to 7. When y is equal to 11, x is equal to 6. When y is equal to 13, x is equal to 5, and when y is equal to 15, x is equal to 4, when y is equal to 17, x is equal to 3, when y is equal to 19, x is equal to 2, and when y is equal to 21, x is equal to 1. So you can count them as y cannot be 0 because we have to form a triangle and it must have length of some side which cannot be 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in total there will be 11 possible isosceles integer side triangles with perimeter 23. So the right answer is 11. Next is question number 5, which reads, how many 3-digit numbers a, b, c bar in base 10 are there with a is not equal to 0, c is equal to a plus b? The bar above a, b, c suggests that a, b, c must be some digit, and you are also given one condition that a should not be equal to 0 and c is equals to a plus b. That means b and c, there should be some digits between 0 and 9, including 0 and 9. So you are given that c should be some digit between 0 and 9, and it has been mentioned that a is not equal to 0 and c is equal to a plus b. As a cannot be 0, if we implement this condition here, we will get 0 greater than equal to a plus b 9. There are no restrictions on b. So if b will 0, then it will come out that a is greater than equal to 0 and less than equal to 9, but a cannot be 0. So in order to make it make this condition, we have to exclude 0 from this inequality. That means a plus b should be less than equal to 9. Only this condition will suffice, where b can be any digit from 0, 1, 2 up to 9. So for a belonging to the set a 1, 2, 3 till 9, we can get b is equal to b belonging to 0, 1, 2 up to 9. For a fixed a, for any fixed value of a, b can be 0, 1 up to 9 minus a. That is, for any a choices, we have 10 minus a choices for b. Therefore, total numbers will be equal to summation 10 minus a, where a is from 1 to 9, which is equals to 9 plus 8 plus 7 plus 1. So this is actually an AP, that is 1 plus 2 plus up to 9. So this is AP, and S9 is equal to n by 2, that is 9 by 2. A1 plus AL, that is 1 plus 9 is 10, which is equal to 45. So your required answer for this question is 45. Now let us move forward to the next question, that is question number 6. Question number 6 reads that the age of a person in a year in 2025 is a perfect square. His age in years was also a perfect square in 2012. His age in years will be a perfect cube m years after 2025. Determine the smallest value of m. Question number 6. Let the age of the person in 2025 be x square, that is a perfect square, and his age in 2012, that is 13 years earlier. X square is age in 2025, then 13 years prior to this. Let the age of that person is y square, which is again a perfect square, that is the age in 2012, 13 years earlier. So let us make an equation, that is x square minus 13 years is equal to y square, which is also a perfect square. So let us rearrange this equation. We will get x square minus y square is equal to 13. Applying the identity a square minus b square, we get x minus y into x plus y is equal to 13. So product of two numbers is 13, and 13 is a prime number. So definitely the factor pairs are 1 and 13. Thus x minus y is equal to 1 and x plus y will be equal to 13, and by solving these equations we get x is equal to 7 and y is equal to 6. So his age in 2025 is x square, that is 49, and 2012 his age is 36, and we want the smallest n such that, as it has been asked in the question, that his age in years will be a perfect cube m years after 2025. So in 2025 his age is 49, so 49 plus m is a perfect cube, so a perfect cube after 49 is you can see that the cube of 3 is 27, cube of 4 is 4 4s are 16, 16 4s are 64. So next cube is 64. 49 plus m. So m is equal to 64 minus 49, which is 15 years later. The smallest value of m is 15, which is your required answer. Next is question number 7. So let us read question number 7. 4 sides and diagonal of a quadrilateral are of length 10, 20, 28, 50, 75, not necessarily in that order. Which amongst them is the only possible length of the diagonal? So we are given total 5 sides, that is 10, 20, 28, 50 and 75. Out of these 5 length, one length is of diagonal and rest are of sides of the quadrilateral. अभी हम लोग को आइडेंटिफाई करना है कि कौन सी लेंथ आपकी डायगोनल की लेंथ होगी. So we know that the diagonal D splits the quadrilateral into 2 triangles. So the other 4 lengths must be splittable into 2 pairs. हम लोग सिर्फ D को जो है वो हमारे लेंथ ऑफ डायगोनल मान रहे हैं. सो रेस्ट साइड्स को A, B, C, E अगर हम लोग मान करके चले, एंड वी नो दैट देयर इज अ प्रॉपर्टी इन ट्राइंगल which is called sum of any 2 sides of a triangle, they are greater than the third side. In addition to it, there is one more property, that is the absolute difference between any 2 sides of triangle is less than third side, that is A plus B is greater than D and mod of A minus B is less than D. अगर हम लोग सभी चीज़ों को ट्राई करें, चेक करें, आउट ऑफ दीज 10, 28, 20, 50, 75 values, the only one that value works is 28. So D will be equal to 28, which only this value amongst these 5 values satisfies these 2 conditions. This is a homework for you. You can check it on your own. So correct answer is 28. Next is question number 8. Question number 8 read the height and the base radius of a closed right circular cylinder are positive integers and its total surface area is numerically equal to its volume. If its volume is k pi, where k is a positive integer, what is the smallest possible value of k? So let us write mathematically what has been given in the question. Question number 8. So let r be the radius and h be the height. So volume of a right circular cylinder is pi r square h and total surface area is 2 pi r into r plus h. And it has been given that volume is equal to total surface area of the right circular cylinder, and that is equal to k pi. So we have been given pi r square h is equal to 2 pi r into r plus h, cancelling r from both the sides and pi from both the sides. We are left with r h is equal to 2 times r plus h. So r into h is equal to 2r plus h. So let us take h to the left hand side. We get r h minus h is equal to 2r. So h is equal to 2r divided by r minus 1. So we committed one mistake. So it must be 2h. So here it must be 2h. So we will get 2 here. And we know that the volume is pi r square h, and volume has been given to be k pi as per the demand of the question. And we are required to find out the smallest possible value of k if its volume is k pi, where k is a positive integer. And also read the question carefully. It has been given in the question that the height and the base of a closed right circular cylinder are positive integers. So k, r and h, they all are positive integers. And in turn, volume is again positive in terms of k pi, again where k is an integer. So definitely by seeing this expression, we can say that r cannot be equal to 2 and r has to be integer, and for any value of r less than 2, the h becomes negative, which gives us absurd result as height of the cylinder cannot be negative. So the least value of radius which is possible from this scenario is r is equal to 3, 4, 5 and up to so on. So let us put these values of r in this expression to find out h, and then we will find out the volume. So for r is equal to 3, h will be equal to 2 into 3, 6 divided by 3 minus 2, 1, which is equal to 6. And let us find out volume. We know that volume is pi r square h, and next r will be equal to 4 and height will be equal to 2 4s are 8 divided by 2, which is equal to 4. So these r is equal to 3 and h is equal to 6, both are integers. R is equal to 4 and h is equal to 4, these are also integer. For r is equal to 5, we get h is equal to 2 into 5, 10, 10 divided by 5 minus 2, that is 3, 10 divided by 3. So h is 10 divided by 3. But here h is not integer, so this is not a valid value. For r is equal to 6, h is equal to 2 6 at 12 divided by 6 minus 2 4, which is equal to 3. We can say that as r increases, the height decreases. The larger values will give smaller height but larger volumes, as volume is proportional to the second power of the radius but single power of height. So as r increases, the value of h decreases but volume still increases. So the minimum value of the volume will be for the least value of r, that is r is equal to 3. So for r is equal to 3, we get h is equal to 6 and volume is equal to pi into 3 square into 6. 3 3s are 9, 9 into 6, 54 pi. So the smallest value for k is 54. That is your required answer. Moving to next question now, that is question number 9. A quadrilateral has 4 vertices A, B, C, D. We want to color each vertex in one of the 4 color, red, blue, green or yellow, so that every side of the quadrilateral and the diagonal AC have end points of different colors. In how many ways this can be done? So question number 9. A quadrilateral has vertices, say A, B, C, D. That is A, B, C and D. We must color each vertex in one of 4 colors, that is red, blue, green, yellow, so that every side of the quadrilateral and the diagonal AC have endpoints of different colors. In how many ways this can be done? This is the question. Edges requiring different colors are AB must be of different color than BC and AD. So let us find out what are the adjacent vertices of 4A. So D and B are immediate adjacent, but we have to consider diagonal AC also. So C will also be counted as adjacent vertex to vertex A. So A has 3 adjacent vertices which are B, C and D. B has 2 adjacent vertices, that is A and C, as we are not counting diagonal BD. So D cannot be considered as counted as adjacent vertex to B. Similarly, for C, we are having A, B, D as adjacent vertex, and for vertex D, we are having A and C for vertex D, A and C as adjacent vertices. So for A, we have 4 choices. 4 choices for A. C must be different from A. So C is having 3 choices. B must be different from both A and C, as B is adjacent to A and C. So B will have 2 choices. D must also be different from A and C. So again D will be having 2 choices. So in total we are having 4 into 3 into 2 into 2, which is equal to 48 choices, which is your required answer. Now let's move to the last question, that is question number 10. Question number 10 reads that the sum of two real numbers is a positive integer n and the sum of their squares is n plus 1012. Find the maximum possible value of n. So let us formulate this question. We have been given that sum of two real number is a positive integer n. So let the two numbers be x and y and their sum be equal to, and it has also been given that the sum of square of these two number is n plus 1012, that is x square plus y square is equal to n plus 1012. There is a relation between root mean square and arithmetic mean, and for any two number we know that root mean square of any two number is greater than equal to arithmetic mean. By root mean square we mean x square plus y square divided by 2, which is greater than equal to x plus y divided by 2. Squaring both sides we will get x square plus y square divided by 2 is greater than equal to x plus y divided by 2's whole square. So which is x square plus y square divided by 2 is greater than equal to x plus y's whole square divided by 4. So let us cut this 4 by this 2. So we get x square plus y square is greater than equal to x plus y's whole square divided by 2. And we have been given that x plus y is equal to n, and x square plus y square is equal to n plus 1012. So we get n plus 1012 is greater than equal to n square divided by 2. So multiplying this inequality with 2 on both sides, we get 2n plus 2024 is greater than equal to n square. So arranging the terms of this inequality, we will get n square minus 2n minus 2024 is less than equal to 0. So let us find out discriminant of this left side of the inequality. We will get b square, that is minus 2 square minus 4 b square minus 4ac. 4 into 1 into minus 2024, which is equal to 4 plus 8096, which is equal to 8100. That is d is square root of d is square root of 8110, which is equal to 90. So n is equal to minus b, that is 2 plus minus 90 divided by 2. So this will return two values of n, that is n is equal to 2 plus 90, 92 by 2, that is equal to 46, and 2 minus 90, that is minus 88 divided by 2, that is minus 44. So from this inequality we are having two factors, that is n minus 46 and n plus 44 less than equal to 0. So plotting them on the number line, we will get minus 44 to 46, and n can be equal to 46 and 44, and we have been asked that the maximum possible value of n, and the sum of these two real number is a positive integer n. So the only positive value of n, which is maximum out of these two values, is 46. So your required answer is 46. So in this session we are done with the first 10 questions of the IOQM which have been asked in 2025. So I hope if you like the video and this video have helped you in some or the other way, then do share and subscribe to this channel, and give me your feedback in the comment box. So we'll be coming up soon with the rest of the questions. Thank you very much for watching this video.